started. So let's start off by reviewing very quickly how to count the elements inside of a molecule. So if we look here, we got KMnO4. So what we want to do is we want to count the capital letters and count those up. Okay, so the capital letters are K, we got Mn, and we got O. Okay, so potassium, manganese, and oxygen. Manganese. There's magnesium and manganese. They're different. Okay, so if you take a look at K, there's no number behind it. So how many Ks do we have? 1. Good. Okay, same thing for manganese, Mn. There's no number, so there's 1. And how many oxygens do we have? How many oxygens? 4. Yeah. Okay. What happened to the one I gave you last time? Oh, did you really? All right, so again, just count the small number behind it, and then after that, if there's no number, it's 1. Okay. Okay, let's go on to the stuff with parentheses now. So if there are parentheses, you just need to multiply everything on the inside by the number on the outside. So if we multiply the nitrogen by 2, how many total nitrogens do we have? 2. Good. Okay, there's no number here, so that's 1 nitrogen times 2 is 2. Let's look at hydrogen now. So there's 3 hydrogens in here. So if we multiply it by 2, how many hydrogens? 6. Yeah, 6. 3 times 2 is 6. And then same thing here. There's no number behind the S. So there's 1 sulfur and there are 4 oxygens. Okay. Okay, so again, just make sure you're comfortable counting the elements inside of a molecule. And if there's parentheses, just multiply the inside by the number on the outside. Okay. So this is what we went over last time, and we'll be using this skill today. And again, the stuff that we talk about today, that's where the majority of the points on your exam is going to be based off of. Okay. Any questions before we move on? Alrighty. Okay, let's move on to the topic for today. Okay, so today we're gonna talk very briefly about different types of elements. Now, please do not write this down. Okay, don't write this down. I just wanted to review a couple things, and there are some things you do need to write down, which I'll tell you. Okay, so the first thing we're gonna talk about is that on the periodic table there are 3 different types of elements. Okay. The first type is metals. And so just make sure you guys write this part down. Just write the word metals. Okay, and we all know what metals are, right? Metals are solids. There's one exception, which is mercury. Metals are good at conducting heat and electricity. We can make wires out of them. If you heat them up, they bend without breaking. Okay, so that's metals. But from a chemicals perspective, the thing that we care about a lot and that I want you guys to write down is this part right here. Okay, metals, they become cations. Okay, so they become positive. Metals are cations. Remember, cats are good, so metals want to be positive. Okay, the second type of element on the periodic table are nonmetals. And nonmetals, they're kind of the opposite of metals. Okay, so metals are usually solid, but nonmetals, depending on what they are, they could be solid, liquid, or gas at room temperature. They're not good at conducting heat or electricity, and they're brittle, which means they break very easily and they crumble. So like if you know, even if you like hit a piece of metal, it's not going to crumble, right? You might make a dent if you're super strong, but nonmetals, if you hit them really hard, they just crumble into little pieces. And from a chemical perspective, the important part is that they become anions. Okay, so they like to become negative. Okay. And the third type are metalloids. You guys don't need to write this down. We're gonna kind of ignore metalloids because we don't talk about them very much in this class. But metalloids are weirdos that kind of do things that metals do and non-metals do. They're all a little bit special, so we put them in their own class called metalloids. Okay, but we won't be talking too much about these guys. The most important thing that you need to know right now is metals, they become positive, and non-metals, they become negative. Okay? Any questions about that part? Okay, so what I want you guys to do is I want you guys to take a look at your periodic tables, because we're going to be talking about very briefly how you can find where the metals are and the non-metals are. Okay, and you guys don't need to memorize this, but there is a kind of a pattern that you guys do need to know, and we'll talk about that pattern. So take a look at your periodic table, and I'll show you guys where the metals are and non-metals are. Okay, so here I have the periodic table. And what we're going to do is we're just going to take a look at it, and you guys don't need to write anything on your notes yet, but the stuff in the yellow are metals, green are non-metals, and purple are metalloids. So if you guys notice, where are all the metals? Where are they mostly like congregated? Yeah, so they're at the center. I also heard left, right? You got center and left. So I need you guys to write that down because that will be very important. The metals, they're located in the left and the center of the periodic table. And that's pretty much all you really got to memorize for the test, okay? Metals are in the center and the left. You don't need to know exactly where they cut off, just know generally where they are. So if you guys have your own personal periodic table, I think I gave them out the first day or had a stack of it. You guys can label them if you want to, and I'll have another stack of periodic tables up here if you want your own personal one for your use. But metals are going to be at the center and the left. Okay, what about non-metals? Where are non-metals located? Where do you see those? Yeah, on the right side. So non-metals, most of them are on the right side. There's one exception though, and that one is going to be hydrogen, right? Okay, so what you got to know is that non-metals are on the right, and you got hydrogen. Okay, so hydrogen is the only one you really got to memorize. And we won't talk too much about metalloids, so you guys don't need to know that. But you kind of see a little staircase going down the right side. That's the metalloids. Okay, so again, metals are on the left and the center of the periodic table. Non-metals on the right. Yeah, what's up?
We have to know like for the non-metals, they're on the right, and then it's like on the test if you want us to write like except for hydrogen.
So I'm never gonna ask you like would like list non-metals or list metals, which one of these are metals, which one of these are non-metals. We're gonna be using them in different problems. So as long as you know generally where they are, it'll kind of lead you the right way. Yeah, you'll kind of see in the problems that we go over today. You kind of just know generally where they are. Yeah, but good question. Yeah, I won't ever quiz you. Like, I won't be like, hey, is selenium a metal or non-metal? You don't need to know something like that. Okay. Alrighty. Let's anybody still need this, or are you guys good? Okay, let's move on then. So like we said, metals become cations and non-metals become anions. Now, one interaction that we're going to talk about today, you guys might have seen this in your other science classes, but when you have a positive and negative charge next to each other, they get attracted to each other, right? It's like dating. You're attracted to somebody that's different from you. Okay? So make sure you guys write that down somewhere. So opposites attract. If there is a plus charge and a negative charge next to each other, they're going to attract together, and in chemistry, they stick together. Okay, so if you got a positive atom and a negative atom, they like to connect together. Okay, so positives and negatives, they attract. Okay, now the other thing that you need to know is that like charges repel. So if a positive and negative, they like to combine together. If I have a positive and positive next to each other, what do you think they're going to do? Yeah, separate, repel. They're going to go run away from each other, right? They're not attracted to one another. Okay. And then same thing with negative charges. If you have a negative and a negative, they're going to push each other away too. Okay. Just keep that in mind. It's going to be helpful for the problems that we do today, which are about to start. But just remember, if you have a positive and negative, they like to combine. And if you have a positive, positive, they push away, negative, negative, they push away. So the common phrase that's used is opposites attract and like charges repel. Okay. All right. Any questions on that? I know it's a lot of like random pieces of info, but now what we're going to do is we're going to combine them together. Okay. Alrighty. So what we're going to be, and the reason why we talked about all that stuff today is because we're going to be learning about something called ionic compounds. So you guys do need to write this down, but an ionic compound is a molecule that's formed when a cation and anion combine together. Okay. So an ionic compound is a molecule that you make when you combine a cation and an anion. So when you got a positive and negative next to each other, we just said that they like to stick together, right? They're attracted to one another and they're going to stick together. And so same thing, when we got a positive ion and a negative ion, they are going to combine and make one molecule. So if you got a positive and a negative, they make one, they're going to stick together and make one molecule. Okay, so we got an example right here with Na and Cl. So if you guys take a look at the Na, what's the charge on Na? Yeah, positive, and specifically it's +1, right? So this is a positive charge. If you look at the Cl, what's the charge on Cl? Yeah, negative. It's -1. So if you got a positive and negative, we said that they are going to be attracted to each other, right? This Na is going to be like, oh, that Cl be looking good today. And that Cl is also going to be attracted, and they're going to come very close together, and then they're going to get married, and they're going to become NaCl. Okay, so they're going to stick together, and they're going to become one molecule. Okay. So that's pretty much what we're going to be doing today. I'm going to be giving you guys different ions like this, and you just need to tell me, hey, what molecule are they going to make? Okay, so pretty simple. All right. Any questions about Na and Cl coming together? Why they make NaCl? Okay, let's move on to the next one. So I got another example down here, and for this example down here, let's take a look at the charges. Okay, so if you guys take a look at the charges, what do you notice about the charges that are different from the previous one? Yeah, one of them is +2, right? Mg is +2, but what's the charge on Cl? Yeah, -1. Now, one thing that you need to know about ionic compounds is that they need to be neutral, which means the positives and the negatives, they need to balance out. Okay, so think of it this way. You guys know how when you're in a friend group, right? There's that person that's super duper happy, right? They have they're extremely positive all the time, right? You go up to them in the beginning of class, like in the morning, and they're already super happy. You tell them you're going to a funeral, but they're excited and they ask if they can go with you, right? They're just always happy. And you can't handle that, right? Because that's too much positive energy. Same thing here. If you guys have a +2 charge and a -1 charge, this Cl right here can't handle the magnesium. The magnesium is too happy. And so they need to balance each other out. So this is +2, this is -1. So what we need to do is we need to add one more Cl. Okay? Because if we do that, we have 2 negative charges, right? And they can balance out the Mg. +2 and then -2. So just to reiterate, magnesium is more positive than chlorine. Chlorine needs to balance out the magnesium, so we need to add one more so that it can cancel out the charge. This is +2. Cl is only -1, so you need 2 of them to cancel out the +2. Okay. Okay, so the way that we would write our answer is we would write Mg2 plus, and then how many Cl's did we need? We needed 2 of them. So we're going to write that there are 2 Cl's. All right, because if we do that, it shows us that we have two of these guys. And so we're gonna write the chemical formula for the molecule that they make. So we're gonna write that it has Mg and then Cl, and then how many Cl's did we need? 2. So we just put a 2 behind it. Okay, so this is the molecule that these two ions are gonna make. You're gonna need 2 Cl's to balance out the Mg. So basically the 3 atoms need to combine to make MgCl. And that's pretty much what you're going to be doing for today's assignment. You're going to be figuring out what molecules are made and how many of each you need. Chemical equation structure. Okay. All right. You guys think you could try some on your own? All right. Let's try it out. Okay. One thing before we move on. If you guys notice, we wrote an equation just now. The thing that we wrote. This would have been our final answer, right? This is your final answer for that previous problem. The stuff on the left side, these are called reactants. Okay? So you guys might hear me use this term pretty often, but reactants are basically like the starting materials. It's like a recipe. You mix these guys, and then you get this one right here. So the reactants are the chemicals on the left side, and then the chemicals on the right side are called the products. Okay, so you combine these guys, and then you make the stuff on the right side. So just some terminology that you guys need to know because I'll be using it. Again, I'm not going to be quizzing you on it. I'm not going to be asking, hey, what are the reactants? What are the products? But just so that you guys know when I use those terms, what I'm talking about. Okay. All right, so I'm going to have you guys try out number 1. Okay, so for number 1, you are going to be looking at two ions. And then you're going to be writing a chemical equation just like we did earlier. So this is what you're going to be doing on your homework. So this is kind of good practice for your assignment. But see if you guys can write the equation, what we just did with the plus sign and the arrows. See if you guys can figure out what we make when we combine Li plus and S2 minus. Okay, so take about 3 minutes. You can work with the person next to you. And then we'll go over it together. So take about 3 minutes to do that. Number 1 together. Okay, so if you guys take a look at number 1, what is the charge on Li? Yeah, +1, right? This guy is +1. And if you look at sulfur, what's the charge on sulfur? 2 minus, right? So do you have more positive energy or negative energy right now? Yeah, you have too much negative energy. So this is the exact opposite problem. Okay, if you're in a friend group and there's a person that's always sad, it kind of brings the mood down, right? So you got to balance that out with some positive people. So what we're going to do is we're going to add another one of the positive people, the lithium. If I add an Li plus, what's my total positive energy? It's 1, but you have 2 of them, so it's going to become +2, right? And then the +2 will cancel out the -2. Okay, so from there, we can write our equation. How many Li's do we have right here? 2, so we just put a 2 in front of the Li plus. We only have one of these guys, so we don't need to write another one. And then we just need to put them together. There's 2 Li's, so we can write Li2, one of this, so S. So let me box what the final answer should look like. Okay, but your final answer should look something like this. So you need to basically write exactly what's inside of the box. Okay, 2 Li plus, and then you combine that with S2 minus, and you make Li2S. Okay. Any questions on how we got that one? You guys chilling? Okay. So we're going to try number 2. If you guys think you can try number 2 on your own, I'll let you guys do that. But I'm going to go over it step by step because, yeah, just so you guys have a little bit more instruction on this. Okay, so let's do number 2. Again, if you're comfortable doing it, you guys can try it on your own. So we have Fe4 plus and we have O2 minus. Okay, so do we have more positive energy or negative energy? Yeah, we have more positive energy, right? So what we need to do is we need to balance it out with the negative energy. Okay, so we're going to balance it out with the negative energy, and we can do that by adding another oxygen, right? So if you add another oxygen, you have the same amount of negative energy as you do the positive energy, right? You got +4. And then now you have -4. So far, so good? Okay, so let's write the equation like we did here, okay? So for my equation, I'm going to write Fe4 plus. And then how many of these guys did I use? Just one of them, right? So I can just leave it as it is. We're going to write plus. And then we're going to write O2 minus. How many O2 minus did we use? Yeah, we got 2 of them, so we put a 2 in the front. And then we're going to draw that arrow, and they're going to combine to make FeO2. Okay, so this is what your final answer should look like. Okay, so when you guys do your assignment and you guys take the exam on October 6th, 7th, this is the kind of answer that you should be giving me. Okay. So hopefully that's not too bad. I'm going to give you guys probably the hardest problem that you'll see on your assignment today, right now. So I'll give you guys about 3 minutes to work on this one as well. And then after that, we'll move on to the last type of questions for today, okay? But the last type of question and the hardest one is going to be this one right here. I'll scroll down. But I want you guys to write the equation when you combine Mg2 plus and P3 minus. Take about 3 minutes, work with the person next to you, and see if you guys can figure that out. Okay, so like I said, this is probably one of the harder ones because it requires the most amount of steps. But let's try it out. So if you look at Mg and P, do you have more positive or negative energy? Yeah, you have more negative energy. So what we have to do is we need to add another one of the positive ones. So let's add Mg2 plus. Okay. But if we do that, you can see that they're still not balanced, right? So do you have more positive energy now or negative energy? Yeah, you have way too much positive energy. So you add another Mg, and then it made the friend group too happy. So you need a little bit of negativity to balance that out. So we got to add another one of these guys right here. So P3 minus. Okay, but if we do that, we run into the same problem we originally had, right? Now there's too much negative energy. It's -6. So what we have to do is we need to go back and add another one of the Mgs. And if you guys notice, they finally balance each other out. So this is kind of like a balancing game. You just need to add positives, add negatives until they finally balance each other out. So if you notice, it's +2, 4, 6, and that balances out with the -3, 6. Okay. Does that make sense? Yeah. Exactly. Yeah. And if they don't balance out and you're adding too many, that means you messed up counting somewhere or you ripped wrong. Exactly. And you just need to add exactly what I give you. Don't change the charge or anything like that. It needs to be the exact same thing. Okay. Yeah, great question. Any other questions? Okay, so let's write the equation and then we'll be all done. So we started off with Mg2 plus. How many of these guys did we use? Yeah, 3. There's 1, 2, and 3. Okay. And then we're going to combine that with P. Okay. How many P's did we use? 2. Yeah, there's 1, 2. Okay, and then so we're going to write down the molecule that they combine to form. Okay. So we use 3 Mgs. So easy way we can do it is just put Mg and P next to each other. We use 3 of these guys, so we can just put a 3 behind the Mg. We use 2 of these guys, so we put a 2 behind the P. And there you go. This right here should be your final answer. And that's about as hard as it's going to get today. So if you're able to get that on your own, then you should be good. Something close to that, then you're on the right track. Okay. Alrighty. Any questions on that one right there? Okay, so we'll go on to the last type of problem that you'll see. And the last type of problem is nothing new. We're just kind of working backwards. So this time, I'm going to give you this molecule, and then you just need to figure out the stuff that was used to make it. Okay, so it's just working in reverse. So let's take a look at one problem. I'll go over I'll just go over one of them with you guys, and then I'll have you guys move on to your assignment. Okay. Okay, so for this problem right here, you have UF4. Okay, and you're gonna assume that F is -1. Okay, so if we take a look at this molecule right here, how many U's do we have? Yeah, just one, right? It's U, there's no number or anything, so that means there's U, so it's just one of them. If we take a look at the F's, how many F's do we have? 4. Yeah, you got 4 F's. All right, so if we take a look at this problem, it tells us that we can assume that F has a -1 charge. Okay, so we're going to assume that it's -1. Okay, so all we need to figure out then is what does U have to be in order to balance out all the F's. So if you take a look at F, there's 4 of them, right? So let me actually redraw this just so it's kind of easier to think about. So there's 4 of these guys. Okay, and only 1 U. Okay, so if you look at all the negative energy, what does U have to be in order to balance out all 4 of these guys right here? Yeah, +4, right? Because if you notice, F is -1 each. If there's 4 of them, you have a total of -4. And if U has to balance all that out, it needs to be a charge of +4. So for your final answer, super duper simple. You just need to finish writing this equation. So we're just going to write plus. We said that we had 4 of these guys. I can erase these. And then I already gave you the molecule that they make. They make UF4. And so there you go. That's your final answer. So I think this one's a little bit easier just because you already have the molecule. I give you one of the charges and you just have to work backwards. Okay. All right, so I'll leave that up on the screen for you guys to copy down or refer back to if you need. I'll let you guys get started on your assignment. Again, whatever you don't finish is homework, and if you guys finish in class, then you have no homework. If you guys want to check the answers, I do have the answer key, so you guys can let me know, and I'll be more than happy to help you out or take a look at the answer key. All right, good luck, guys.